All right, this is your reaction enthalpy video. So I'm going to show you guys how to do some what we call thermostoichiometry problems, which is just how it sounds. It's stoichiometry with thermochemistry in it. Okay, so just to kind of show you what kind of stuff you'd see. The question itself is, what is the heat change? Okay, which is delta H, right? What is the heat change in kilojoules accompanying the reaction of 37.5 grams of glucose? Now, this right here is my reaction enthalpy. Okay, this is the number of kilojoules that gets released or absorbed in this reaction when it's balanced. Okay, so what I mean by that is, in this case, I have a positive value here of 4,360 kilojoules, which means if this reaction right here was to take place in these amounts, 1 mole of this is going to produce 2 moles of this and 2 moles of that, okay? If it happens in that amount, then I'm going to produce, or in this case, I'm going to absorb, since it's a positive value, and it's endothermic, 4,360 kilojoules of energy. Okay, so it's endothermic because the positive value, and then it also tells us it's going to be absorbed, or it's going to be as a reactant in this case. So, looking at the problem, okay, I have 1 mole of glucose gets broken down into 2 moles of ethanol and 2 moles of carbon dioxide. Okay, you are not expected to know what, distinguish ethanol from glucose, anything like that. That's not what this is about. Okay. What it is about is I want to know how much energy is accompanying the reaction that is involving 37.5 grams of glucose, which is right here. So I'll go ahead and start with what I'm given, just like all dimensional analysis. Okay, 37.5 grams of glucose. I'm just going to go ahead and put capital G, so I have to write the formula out all the time. Okay. And the whole point of this is to get to kilojoules. Okay, get to energy, get to that thermal energy. What's that heat change? Okay, so knowing this, I know that there is, for every 1 mole of glucose, it's going to produce or absorb 4,360 kilojoules. So I can use this equivalency statement as a conversion factor in my dimensional analysis. So obviously it's 1 mole of glucose. I'm not at moles yet. I'm still at grams. So if I want to go from grams of glucose to moles of glucose, I need to use the molar mass of glucose, which is 180.18 grams of glucose is every 1 mole of glucose. Okay. Now that I'm at moles of glucose, I can go to kilojoules because this conversion factor will let me. Okay, or this equivalency statement will let me. So 1 mole of glucose is 4,360 kilojoules of energy. Okay, so my moles of glucose cancel out, okay, which I'll make red. Moles of glucose, red I said, red. Red will cancel out, or that, red cancel out. Grams cancel out, I'm left with kilojoules, which is what I want. Okay, so I do the math, I end up with, let's see here, 1,63500, made that a little too big, and then do the bottom, which is 180.18. Now, of course, if I look at my numerator, it's not going to be 163,500 because I only have 3 sig figs. So it should be 164,000. Change that to 164,000, which I end up with 910.20 kilojoules, which again is not right because I can't have 3 sig figs on top and then end up with 5 sig figs in my answer. So my sig fig rules need to apply. I end up with 910 decimal kilojoules. Remember that decimal is important because if I don't put it in there, I only have 2 sig figs and my answer is not as precise. Okay? So, next one. What is the heat change accompanying the production of 97.6 grams of carbon monoxide? Okay, my delta H is equal to, should be black, I see. Oh well, we're using green. delta H is equal to 782 kilojoules, meaning that if this is endothermic, right, plus positive charge, that means 782 kilojoules is a reactant. So it's 780 kilojoules plus 4 moles of chloroethane with 9 moles of oxygen is going to produce 8 moles of carbon monoxide, 10 moles of water, and 2 moles of chlorine gas. Okay? So, let's go ahead and take a look at what we have first, or take what is given, which is 97.6 grams of carbon monoxide. Okay? So if I have 97.6 grams of carbon monoxide, I know that this much energy is per 8 moles of carbon monoxide, so I need to get to moles. Okay, put that over 1, and I end up with, let's see, 28.01 grams of carbon monoxide for every 1 mole of carbon monoxide. Okay, now this is important. A lot of people make this mistake. I am now able to get to energy because I'm at moles of carbon monoxide, but look at the equation. I have 8 moles of carbon monoxide for this much energy, which means I can put 8 moles, or I need to put 8 moles of carbon monoxide here in order to use this value of 782 kilojoules. Okay? If I don't use 782 kilojoules, I use a different value, like an eighth of that, then I can go with 1 mole of carbon monoxide, but there's no reason to do that extra math. Okay? Look at the value that's given in the problem. Look at the molar ratio of the substance in hand, which is carbon monoxide, with the energy value, which would be positive 782. Okay? All right, let's take a look. Cancel moles out, cancel grams out. I'm left with kilojoules. So, doing my math, I end up with, let's see, 76323.2 over 224.08, and hopefully we're like, no, that doesn't work because of sig figs. So that number gets scratched out, and I should end up with 3 sig figs in my numerator, which would be 3600. And then also, my denominator only has 4 sig figs, okay? Because this number right here has 4 sig figs. This value has nothing to do with sig figs because it is a molar ratio pulled right out of the equation, okay? So don't use this guy right here, okay, at any point for sig figs. All right, so that should be 224.1, okay? I do the math, it should be 340.47, which, again, I have 3 sig figs in my numerator, so that's toast, and I'll go 340 decimal kilojoules, okay? That's my answer. Now, both of these problems, both this one and this one, were involving solving for energy based on the number of grams of either a reactant, like I did in this problem, or a product, like I did in this problem. The next problem is I have a certain amount of energy change. How many grams are reacted? How many grams of a certain reactant were involved in that process? Okay, or I may say how many grams of a product was produced when this much energy is released, okay, or absorbed. In this case, it's released because delta H in this case is equal to a negative value, so this would be exothermic, right? Because it's going to be giving energies leaving the system. All right, so let's take a look at what we have. If a reaction has a heat change of negative 2030 kilojoules, what quantity of, in this case, it's lactic acid, in grams has reacted? So here's my balanced chemical equation. I'm telling you right now, I'm not going to give you the balanced chemical equation. I'm going to give you the names, and you'll have to write the equation out and balance it. Okay? I'm not going to give you the balanced chemical equation. I won't even give you the formulas. You need to figure that out because you're studs, and you're awesome, and you should be able to do that. Okay? So I have lactic acid reacting with oxygen gas to produce 3 moles of carbon dioxide and 3 moles of water plus, right, 4,020 kilojoules. And the reason why it's on this side is because it's exothermic. It's a product. It's a negative number, which means it's being released from the system. Okay, so what was I given in this problem? I was given an energy value. So I'm going to start with that energy value of 2030 kilojoules. Okay? Now, it's pretty much the same stuff we've been doing for the last two problems, but now we're going to go backwards. Okay? So I have kilojoules. Now I need to get to grams. All right? So, looking at this, I have, let's see, my delta H value, my molar enthalpy, okay, this is my molar enthalpy right there, is negative 4020 kilojoules per mole, and I'm looking at this substance, I'm looking at lactic acid. For every 1 mole, and just to make things easier, lactic acid, okay? I happen to know that 1 mole of lactic acid is 90.09 grams of lactic acid, and I am where I want to be, right? Because my moles will cancel out, my kilojoules cancel out, I'm left with grams of lactic acid, which is what I was looking for, okay? So, I do the math, I'll go ahead and move it down here a little bit. I end up with a negative, right, 182,882.7, which is ridiculous. We'll get to that in a second. And negative 4020, since I'm just multiplying that by 1. Okay, hopefully we went, that's not right. Okay, so with my sig figs, it should be negative 183,000. Okay, I do my final answer, which would be 45.52, which should be grams, but of course that doesn't work either because I need my sig figs, which would be 45.5